You must be aware about different data formats. So for example, CSV, the comma separated values, JSON, HTML, XML, and so on, right? These are the common ones used in data analysis. CSV, which is, as I was telling you, comma separated values, where columns are separated by commas, and each line pertains to all records of a particular entity, right? One line, one entity, all its records. And then but at times the data itself needs to use comma. So for example, in one of the rows, whatever value you have, you need to separate. For example, you have an address column, you might need to separate using commas. Now in that case, separating columns by commas could become a problem, because you are trying to separate column by commas, and now suddenly inside one of the column you need to use a comma, so it will kind of become a problem. So in this case, we also use quotes and other type of separators. JSON, which is a JavaScript notation, stores values in attribute pairs. Normally you will read about JSON being used for data communication between servers and clients, right? Then the famous one, HTML, extensively used for web designing. I'm sure you have used HTML at some point of time. It's a markup language widely used on the internet. So when we talk about internet, most of the data on the internet will be HTML formatted. On the other hand, XML, or extensible markup language, is a generalized version of HTML. Okay, in HTML, tags have a set meaning, but when it comes to XML, you can define your own tags to store the information. So whatever format you process, you have to be careful about the structure of the data. Whether you have CSV, whether you have JSON, HTML, XML, just be careful of what kind of data you are using, how the data has been formatted, and so on. Otherwise, you will end up with data that will be of almost no benefit. For example, if you don't take care of an address column, the address being separated by commas inside a CSV, then you might run into data that's irrelevant or wrong, because you would have separated the data inside the same column. So please be careful about the structure of the data that you are dealing with. With these varied formats of data, we also have, so there's on one end there's the formats of data, and on the other hand we have extensive quantity of data. So therefore we require distributed computing. Distributed computing becomes necessary not only for the purpose of processing, but fault tolerance as well. Copies of data are stored across multiple nodes. This is something that we have discussed in our past classes, that how the data is stored across multiple nodes, and what is fault tolerance, and what is the requirement for fault tolerance. So if a machine goes offline, basically the same data can be found on other nodes as well. HDFS takes care of that as well. It splits the files commonly into 64 or 128 megabytes, and then replicates the chunks across the network on various nodes. So you could probably have your own setup of the distributed network, or you can even use cloud services such as Amazon Web Services. Particularly, you will see S3, which is also known as Amazon Simple Storage Service. These are handy terms that you should remember once you are deploying over the cloud and so on. Okay, now let's talk more about a Spark program itself. The first component of the program is the Spark context. We have used it, but I'm going to elaborate more in a while on it when we take an example. It is the starting point for Spark functionality. It connects the cluster with your application. As I told you, we have already seen it previously when we were using the first time when we used a Spark on the Google Colab, which is the last notebook. We just quickly wrote the code and went through it. Now we're going to talk more about it. So what we do is we create a Spark conf object to specify the information about the application, such as its name, master node's IP address. If you remember, we gave it a name. I think we called it maps and lazy evaluation, something right there, if you still remember. So similarly, other information such as master node's IP address and others are given there. So if you're working locally, then you can just set the local IP address to, you will just set it to local. If you want to read data frames, you need to use Spark context, you need to use the Spark session. So if you want to create a Spark session, you can use the get or create, which we're going to use shortly. What get or create will do is that if you have a Spark session already running, it will use that. If you don't have a Spark session running, then it will create. So it's good to use the get or create in order to check whether you have a Spark session already running or it needs to be created. So let us implement these details using our next Colab notebook. So let's look at another notebook and try to run some more code to understand what we have been discussing. Just going to my Google Colab, creating a new notebook, and there I have it. So first of all, I'm going to try to connect. This is to make sure I have all the resources from the Colab. Okay, it's connected. So as you know, first of all, again, we have to set the environment, download the Spark. It's good to do it, just to do it every single time, because usually Colab will delete the resources once you exit the Colab notebook. It doesn't save all the environment variables or the files that you upload. So I'm going to quickly, I've kept this open, I will just copy this one in here, and then I'll just give it a run. So as a good practice, whenever you open a new Colab notebook, just get all these environment variables, download them, set up your environment. You may have it already there, but sometimes when you exit the Colab, it might just delete all your resources, so it will be very difficult for you to find out. I mean, you will spend time in finding out what the error is. So as a best practice, when we are doing it on Colab, you can just set up the environment. I think that's the first step of setting my environment is complete. I'm just going to close the output, insert another code cell. Again, I'm just going to copy that, setting my environment variables. It's same steps, not much of a difference. And after this, having imported and set up my environment for my Spark code to run, the next thing I'm going to do is import find Spark. As you know, we are running it locally, so I'll import find Spark. And of course, I also need to import PySpark, and from PySpark I would say import the Spark configuration, and from PySpark.sql import Spark session. Now at this point of time, it's important to talk about the Spark conf and the Spark session, which we're importing from PySpark. What is Spark conf? Spark conf is basically a Spark configuration. It's the configuration for a Spark application, whereby we can set various Spark parameters as key value pairs, as we will see in another cell. What is a Spark session? A Spark session is basically a single point of entry to interact with the Spark functions. It allows us to program Spark with the underlying data frames and data APIs. So this is the session. It gives us the ability, the Spark session gives us the ability to interact with the Spark, program with data APIs and data frames. Okay, so I'm going to run this and see if everything is all right. Okay, looks all well. I'm going to insert another line. So I'm going to run this and see if everything is all right. Okay, it looks like everything's well. We've been able to set the parameters. We want to still verify whether the changes went through or not. So what we can do is we can just say Spark context dot get configuration and dot get all. Let's run this. Okay, there you have the driver port, the app ID. You can see the master, and basically it's all there. you can see they're done. It is I was looking for it. Yeah, the name of the Spark app, which will actually tell you from your own code whether the above changes have been implemented or not, because we are getting other parameters in the get all as well. But since we set in 11 we set read and write as the name of the app, you can see the name of the app is right there. So that means the changes did go through. You can also just run Spark and it will give you, yes, the Spark session is in memory, context is here, the version, the master is local, meaning to say you're running it locally, and the app name is read and write. So this is a shorter version of what you have seen at the top using just the Spark function. So the app name is, so you've seen the app name is exactly read and write as we set it, right? So basically all these changes have gone through. We have been successfully able to work with the Spark configuration and the Spark context itself. Okay, now moving further, as I was discussing that we need to load our dataset before we can perform any activities on the dataset. So let's create a data frame from a dataset that I have. It's a small dataset that I just copied from other places. You can find a lot of datasets that are available online, so you can use them. So I'm going to load that dataset now, which is available on my local machine. So I'm going to set the path to, first of all, to data slash, the name of my dataset is COVID-19 key countries. I think I have downloaded it from one of the European websites, European government websites, but not the entire dataset. I just copied a part of it so that the processing doesn't take a long time. So once you set the path, you've seen I set the path to data under slash COVID key countries pivoted dot JSON. So the thing is that, and I told you the dataset exists on my local hard drive. So can you directly pick it up from there? No, I actually have to upload the dataset. So you click on this folder icon. Basically you can create a new folder, and that's where you can upload the data sets to into Colab. So I will just create the data folder as I have set the path, data slash, okay, there I have it, and then I can just create upload file. So I have it here in my data. So the name is key countries pivoted, so this dataset, and I'm going to upload it. See, it says reminder, uploaded files will get deleted when this runtime is recycled. This was something I was reminding it earlier. So if you upload files, the next time you come back, Colab will not store them for you. They are only temporary. Okay, so I'm going to click OK. So I'm going to check. Okay, my dataset is uploaded. Normally you will see a small yellow icon going round and round if the dataset is still being uploaded, so you have to wait until that the circle icon, the progress icon has done its job. But in my case it's faster. So okay, and then now I want to create a data frame. I want to upload this dataset into a data frame. So I'll call it user log, the name of the data frame. You can name it whatever you like. I will say read my dataset spark.read.json. This is a JSON file, and from where I want you to read it from path. So the value of the path already points towards the dataset. So now I'm trying to load this dataset into my Spark. So here we are, it's trying to read my dataset. I'm going to hide this. So it's done. My dataset, I have uploaded it into the Spark. It's in the user frame user underscore log. Let's have a look about what is inside the dataset, right? You can go and open the JSON file and look at it, but we want to look from here, of course. So we will say user, and that's where we have loaded the dataset. We will simply say print schema. We want to say, see what is inside, what's the structure of the data. So let's run this and see what do we have in the dataset. Okay, so basically just to give you an idea of this dataset, since I have gone through it already, The COVID-19 key countries is basically what they have done is on a particular date they have pivoted the key countries. They have set the values for key countries like China, France, Germany, Iran, Italy, Spain, US, United Kingdom. On that day they have set a comparison. So each row is a comparison of how many cases there were in China compared to France, compared to Germany, and so on. So this is what the data in the data set is. So now as you can see, that's why the name of the it's showing you the schema. So the first column is China, the second column is date, third column is France. So based on so each row represents one date and tells you about all of these countries. So that's the schema. Let's try the another one, which is called, so your data frame is user underscore log. Again, this is where we loaded it. So you can use the describe function and see what it gives us. So this will give us some more information about our data. It has what has returned output is basically the columns we have in this data frame, and then also it has given us the type of the data, just like the previous one. Okay, just like the previous one, you can see that string summary is string, China is string, date is string, and France is string, and Germany is string, and Iran is string, and so on. So basically it also gives you a view about your data frame itself, just like as we saw in the print schema previously. What if you want to look at a particular record? So I will just say user underscore log. I'll use the show function, but I only want to see for, let's say, the first one. So n equals 1, run it. There you have the first top one row. So you have on the date 22 January 2020, you have 548 cases in China, and almost the other countries are 0 except for US had 1 case on that day. Now I'm not delving into the validity of the data set at this point of time, which I think it is actually correct, but it's just we want to see how the data behaves, that's all. Okay, so you have this data set giving you this information in one row. If you change the value of n to something else, probably you will get different numbers, depends if numbers change on those days or not. So this way we are looking at the first record in our JSON file that we have uploaded into our data frame user underscore log. What if we want to look at let's say first 5 records? So again, our data frame user underscore log dot, we'll use the take function this time, and we'll say okay, we want to know about 5 of them, and there you have. You can even compare the first one. You see the 22 January 2020 to your previous result. It's the same result, just so that you know that it's displaying correct results. So now we have the 22, 23, 24, 25, and 26 date rows giving us different numbers. Seems that the numbers are changing. Okay, so this is how you can have a look at the first few records. You just need to set the parameter for the take, and then it will do the job for you. So in other words, we can say that we have successfully loaded our data into this frame user underscore log. Let's say now, what if you wanted to save it to a different format? You wanted to change it from JSON to XML, JSON to CSV, and so on. So let's try to get this JSON into a CSV. I'm going to set where to store it. COVID-19. So I'm going to name it KeyCon pivot dot CSV. Run it. Okay, the next thing I need to do is my data frame, that's what I want to convert, log dot write dot save function, in this case where out.path. I already said that one, and I want to save it in what format is basically CSV. And set the header true. That does have a header, and I'm going to run it. Let's have a look if the file was created. We have set the out path to data folder, which is basically here. Previously we only had one file, and of course the name of the file is also changed a different name. You can see we have COVID-19 keycon pivot.csv, which was just created after we ran our command in 21. Okay, so that's the conversion. Okay, but how do we know that actually the data was properly copied? When the transformation happened, the data is still valid. It is the same data that was in the JSON file. How do we know the converter actually worked? So we're going to load that first into the data frame, because that one is in the new data set. The CSV data set is in Colab. We need to load it into our Spark session. So we're going to load it into our different data frame, and we're going to call it user_log_2. And again, what we did previously is spark.read. In this case, we are trying to read CSV. And where is that CSV? Out.path. So basically, because out.path points to data slash the dataset.csv, and I'm going to say yes, this dataset does have header which is set to true. So let's load it into the data frame. Now I want to insert another code cell, and because I want to check whether it has been transformed, where the data is the same or not, since I just converted from one format to another. So I can print the schema using the same way I did previously. My data frame dot print schema, and I'm going to run it. So there I have it. It's exactly the same if you compare it to the previous one here, all the way up here. This one, no difference. So that means the conversion was successful. Data has not been lost. It has been copied in the same way. Let's confirm further. And of course, confirmation also here means that you can use the same commands on a different data set. In this case, we have a CSV data set. So let's say we want to look at 2 records instead of 1 instead of 5. So these are your 2 records. I think you can see 22, 23 same. US having 1 case, and the cases of China increasing. So let's try something else. First of all, our own data frame. We got to, because we're using that data frame within Spark. So we want to see, let's say this is one more date. We want to see all the dates that are there. We didn't use this previously. Function, run again. Okay, there you have it. So it's basically showing the top 20 rows, 23 until 22 January until 10th of February. Okay, so let's try one more. In this case, we just want to do what we did previously. Just look at using the take. Just look at just the one record, the top record, just in case you're wondering, because previously we looked at 2. If you look at 1, it will still give you the top row, just like it gave the result in terms of the JSON file. And there you have it. You have now been able to load the data, set the paths, start the sessions, and so on. Look at the structure of the data file after loading it into Spark, and then look at the schema, print some records so that you can understand the data inside it without actually opening the data file itself in some other way, right? We have done everything inside of this Spark session. Now that we have worked on data frame, it's time to wrangle some data. Of course, this is also a part of data wrangling, but we want to look further into it. Primarily, there are 2 ways for manipulation. So we are now talking more about manipulation. So there are two ways. First is imperative programming using data frames and Python. The second one, which is, I guess it will be much easier for all of you since it is programming using SQL or SQL as we know it.